Hello guys, here again Gabby. We're going to talk about a little bit about clean code and in .NET microservices. We know that most codebases do not fail because of performance, they fail because no one understands them anymore. Millions lines of code and a lot of complex things that should be very simple, clean, and so on. So the code works, but nobody wants to touch it. All the changes we want to do are risky. Fear slows everything down, and the senior guys do not know what to do, and that's not a technical problem. It's a clean code problem. So I will try to explain in my own terms what clean code actually means and in the stack that we are working on, that is .NET microservices, and how we apply it and how could we apply it like in production code and so on. So code is read far more times than is written, because we are in if we are in a team, if we are working for a client or for our company in a software factory, we have a team of a bunch of developers. We have a lot of code. We have to ship code, and the code must be readable for other one. It's like uh, in the sprint you have to code you have to change a code or update a code or optimize a code that was written by a guy that is not there anymore in the company. Uh, if it's not okay, if it's not clean, it's not simple, it's going to be a mess. Okay, so if the code is hard to read, it will be hard to maintain, and eventually it will be replaced. So we don't want to replace, we want to update, we want to read, we want to get better things done and not replace everything, because if something works and we can read it, why what are you going to change? So with this, what clean code really means is it should be easy to read, easy to understand, easy to maintain, and easy to change. Let's repeat: read, maintain, change, and understand. We read it, we understand it, we maintain it, and we can change it if we want. That's the steps, okay? It's not about working. We must read the code properly, understand it, change it if we want, and maintain it, okay? We should be able to understand the intention, the behavior of the code quickly and modify the code without fear. It should be clear and simple, okay? It's not about style or whatever. It's communication through code. It's a language as we were spoken, English or Spanish or French or whatever. We must be clear, concise, to the point. It must be clear for the other what we are trying to say. Okay, how can I apply it in real situations? For example, we need to implement an intentional naming for the variables, for the classes, for the abstraction layers, for everything. Okay, names should be explained why something exists, not what type it is. Okay. Um, Small functions with a single responsibility. The functions should do one thing and do it well. If we have a method start doing orchestration, validation, mapping, and persistence, it's all wrong. We have to encapsulate it in different things. One function must done has to do only one thing. That's the primary objective. One function, one thing to do. Okay, so we have to have as a third rule a clear separation of responsibilities. As we already talked in in other videos, we have the API, the application layer, the domain layer, the infrastructure layer, where the API handles transport concerns, the application orchestrates the use of cases, the domain layer contains business rules, and the infrastructure handles technical details. Okay, the API handles the transport the concerns of the client, the input, the output, it validates, it has the middleware, it has all of that. Okay, the application knows what to do, know how to do it. It works with it orchestrates. It depends on the on the on the domain. It uses abstractions like interfaces to do things. Okay, the domain is the core, is the business rules, are the business rules. It depends on nothing and is the main key to all of our microservices and the use case of our business. And the infrastructure does the things. The connection with databases, the use of cache, the use of telemetry, the observability, the entity framework core, the HTTP client factory if we want to communicate with other providers, and so on. So it handles the technical details. When these boundaries are respected, the code becomes easier to reason about and easier to evolve. So, for example, if I tell you dry, what is dry? Dry is don't repeat yourself. Okay, we are going to talk about don't repeat yourself, errors, and testability. That's the real stuff. We want to avoid the duplication, but without over engineering. Okay, we don't want to abstract on the first application. If we have to make, if we have to code a feature and it has to be shipped today, and we need to create I don't know, a vertical slice CQRS handler that could repeat with another feature, we are not going to optimize the two features into one and abstract the classes, the handler, and so on with the commands. We have to get the things done. Okay, so we do not abstract on the first application. We wait until the pattern clearly emerges eventually, and we will have time. First repetition appears, then the intention becomes obvious, only then we do abstract. Okay, we repeat, the pattern appears, the intention is obvious, we have the time, we abstract. That's it. Premature abstraction makes code harder to read, not cleaner. If something works and we have to implement another thing, as I said before, that has a similar behavior, perhaps we do not need to abstract that behavior, that thing. We can do it later or in a third repetition when intention is clear and we know, hey, we are repeating the same things over and over. Let's abstract that. Error handling is also part of the clean code. Errors are not hidden, they are explicit. The business rules violations become domain exceptions and technical failures are handled consistently. The middleware that resides on the API translates the errors into HTTP responses. This makes the behavior predictable and failure modes clear. In other previous video, I talk about middleware, so you can rewind and go to that video to watch a little bit more about middlewares. Another key rule is that if the code is hard to test, it's usually bad designed. The test should be very simple. The clean code naturally leads to testable code. When dependencies are explicit, responsibilities are clear, and logic is isolated, test becomes simple, not painful. So, consistency beat cleverness. Okay, clean code is also about consistency. We have to be consistent with what we are doing across all our microservices. We try to do or use the same structure, the same patterns, and the same naming conventions. This reduces the cognitive load. So, for example, if we are working with a team with multiple microservices, if we know the patterns, the structure, the layers are the same, we know mentally that okay, it's similar. I know where this bug can be, and so on. So, as a final takeaway, clean code is clarity. We need clarity. Okay, it's a code that communicates the intent. respects the responsibilities, handles error gracefully and explicitly. It's easy to test and it is consistent across the system. Not complex, not clever, just clear. Okay, just clear. We need to be able to read, to understand, to maintain, and to change. It needs clarity. The code that we read should exuberate and be explicit with the intention, with the behavior, what we are trying to say. It's a language like Spanish or English. Okay, so hope it helps, and see you next time.